Now let us look at sum number 3 of exercise 6.2. The question says, in figure, if LM is parallel to CB and LN is parallel to CD, prove that AM over AB is equal to AN over AD. So this is the figure given. It's given that this LM is parallel to this line segment CB and LN is parallel to CD. This LN is parallel to this line segment CD. We have to prove that AM over AB is equal to AN over AD. Okay, so we will use basic proportionality theorem here. First we have to write what is given, because from the given information only we can do the other steps. LMCB and LN is parallel to CD. What we have to prove? We have to prove AM over AB is equal to AN over AD. Now we can start the proof. Now you see this figure carefully. There are two triangles, triangle ABC and triangle ACD. So I will take this triangle ABC. In this triangle I will apply basic proportionality theorem. So here LM is parallel to CB. Then I can write, let me take this triangle like this here. So this triangle is like this. This is L. So LM is parallel to CB is given. So I can write by basic proportionality theorem that first I will look at the right hand side. AM over MB is equal to, now I will go to left hand side, AL over LC. This is the triangle I took from here. So AM over MB is equal to this line segment AL over LC. From this triangle we applied basic proportionality theorem. Why did we do this? It's because it is given LM is parallel to CB. LM is parallel to CB. So in triangle ABC, so we can write AM over MB is equal to AL over LC. Reason is by basic proportionality theorem. If you want more content like this, please click the subscribe button. Let this be equation number 1. Now I will repeat this process in triangle ACD also. So this is triangle ACD. In this triangle you can see if you shift it like this LN is parallel to CD. So we can say AN by ND is equal to AL by LC, because again basic proportionality theorem. You can visualize this in this triangle. You have to first take the left portions, take only from one side AN or ND. Now go to the other side, right hand side, AL by LC. So in triangle ACD is given LN is parallel to CD, so we can write AN by ND is equal to AL by AL over LC. The reason is same, basic proportionality theorem. Let this be equation number 2. Now you can see that AL over LC, AL over LC. So both have AL over LC in the right hand side part, here also and here also. So that means the left hand side will also be same, LHS part will also be same. So AN over ND will be equal to AM over MB. We can write AM by MB is equal to AN by ND. AM by MB is equal to, now we can write this AN by ND. AN by ND. The reason is from equation 1 and 2. Now next step is we will take reciprocal of this. So we will make it upside down. So MB will come in numerator. So MB over and AM will come in denominator. MB by AM will be equal to, if you make the change here, you have to make the change in right hand side also. It will become ND by AN. ND by AN. This implies. Now we will add 1 on both the sides. Add 1 on both the sides. So MB over AM plus 1 is equal to ND over AN plus 1. So this implies, now we have to cross multiply this am is in denominator, so am into 1 into mb into am into 1 plus mb into 1 is in denominator. So we have to do cross multiply. So here there is 1 in the denominator, so mb into 1 is mb plus symbol am into 1, am into 1 is am whole divided by denominator. What is there? Am. Let it be as it is. Am is equal to, now do the same here, nd into 1 is nd, nd plus an into 1 is an whole divided by what is in denominator, it is an. Now you can see carefully what is in the numerator, mb plus am. Now look at the figure, mb is this line segment mb plus am is this line segment. So mb plus am is this complete line segment ab. So in numerator I can write ab over am will be as it is equal to, now what is nd plus an? This is nd, this is an. nd plus an is this complete line segment ad. So ad over, now denominator an is there, let it be as it is, an. Now if you reverse it, if you take the reciprocal, you will get what we had to prove in the question. So take the reciprocal, this denominator will come in numerator and this will come in the denominator. So am, this implies am over ab is equal to an over ad. So hence proved, we have proved it finally.